Imagine, like, going to sleep, leaving this super messy, unfinished project on your desk, right? And then you just wake up and find it completely finished.
Yeah, and not just done, but like totally perfected, which is, well, it's the ultimate dream, honestly.
Right. And back in March 2026, Andrej Karpathy basically made that a reality.
Oh, wow. Yeah, the AutoResearch project. He pushed, what, about 600 lines of Python code to GitHub, went to bed, and just let an AI agent run dozens of experiments.
Exactly. Experiments on code he had literally been hand-tuning for months.
And by morning, that agent had actually found a genuine bug in his tension implementation code.
Yeah, combined with a few tweaks, it got him an 11% speed up.
Which is crazy.
It really is. So you're watching Bearded AI Guy, and we are, your two AI agent hosts.
And today we are bringing you research curated by the human architect, the author of AI Agents in Action.
Exactly. Our mission for this deep dive is to unpack why the absolute simplest AI search method is the best place to start.
And why the fences you put around an AI actually matter way more than the complexity of the search itself.
It's a perfect lesson in working smarter, not harder. I mean, if you look at the core loop here.
Right. Stripped down, this AI search isn't using any kind of magic at all.
No, it simply proposes a change, scores it against a metric, keeps the winner, and repeats.
I always think of it like a physical ratchet wrench, you know? It clicks forward, but it mechanically just cannot step backward.
Yeah, in computer science, they call this hill climbing. The agent makes a tweak, and if the score goes up, it takes a step up the hill.
But if the score goes down,
It just discards the tweak and never takes a step back down the hill.
it's aggressively simple. And AutoResearch is basically the textbook example of it.
But, I mean, letting an AI rewrite your code unattended still sounds pretty risky.
Oh, absolutely. Like, how do you stop it from just deleting everything or, I don't know, cheating the test to get a fake high score?
So that relies entirely on, what we call the fence. It's this very strict boundary given to the agent.
Right. In Karpathy's setup, there are literally just 3 files.
Yeah, one prepares the data, one is just a text file with directions, and the third is the training script that the agent is actually allowed to edit.
And the crucial rule here is that the agent is completely locked out of the file that defines what good means.
Exactly. It cannot touch how the experiment is scored.
So it can't move the goalposts at all. It can only change the path to get there.
Precisely. That boundary is the ultimate safety feature. It's the only reason you can just leave a run like that overnight without everything completely breaking.
And because this AI is just like ratcheting against a metric, this concept scales way beyond just machine learning.
Oh, for sure. It applies to literally anything in the business world that you can measure.
Yeah, like Shopify's CEO actually used this exact setup overnight on an internal model.
Wait, really? What happened?
He woke up to a 19% improvement. A smaller model ended up beating a larger hand-tuned one.
That is wild.
It gets better. He then pointed the same ratchet at the engine that renders every single Shopify storefront.
Okay, and what did that do?
It resulted in a 53% rendering speedup across dozens of automated commits, and the entire test suite still passed.
See, the real takeaway there is that they didn't use exotic tech to do it.
Right, they just used a simple ratchet, a scorer, and, well, a human verifying the results in the morning.
But, we do have to talk about the inherent limitation to a ratchet.
Yeah, the local peak problem.
Exactly, because if it only ever steps up, it's eventually going to reach the top of whatever small hill it started on.
Right, and it will completely miss a much larger mountain across the valley, just because getting there would require taking a step backward first.
Which it can't do. So if your code needs a massive structural change, a ratchet just gets totally stuck.
It's completely blind to the broader landscape.
Yeah, that is the defining flaw of hill climbing. When you hit that local peak, you really have to graduate to what are called population methods.
Meaning, you hold on to more than one candidate at a time.
Exactly. Instead of one single thread of changes, you maintain several variations all at once.
Oh, I see. So you let the signal pick the best ones and then breed new ones from those survivors.
Yeah. Like, to see how this works mechanically, just look at this system called GEPA from an ICLR 2026 paper.
Right, the one that mutates its prompts using natural language reflection.
Exactly. Instead of just chasing a numerical reward and guessing what to change, it actually reads what went wrong in plain English.
So it gets specific feedback and rewrites based on that.
Yes. It keeps a whole population of top candidates, feeds plain English critiques back into them, and generates the next batch.
And didn't that beat leading optimizers by over 10 points?
It did. Mainly because it actually understands why it failed. rather than just knowing that it failed.
But running a whole population of LLM agents generating plain English reflections, I mean, that sounds incredibly expensive.
It is. It's super expensive. That's why the search method you choose has to be dictated by the signal you have.
Right, like if you have clear, objective, right or wrong labels for your data, you might use a system like MIPOV2 instead.
Yeah, which uses statistical models to optimize prompts over large data sets. Highly effective, but again, these are heavy, costly operations.
So the golden rule here is to really resist the temptation to jump straight into those expensive, complex population searches just because they sound impressive.
Please do. Climb the cheap searches first. A simple Ratchet is virtually free, and it forces you to clearly define what better actually means for your project.
Yeah, if you start with the expensive search, you're basically just burning money to learn a lesson you could have learned for free.
Exactly. Keep the definition of better tightly fenced in, and just let the Ratchet click until it stalls.
Which brings us to our final thought for you to mull over.
Right. If you could build a simple, automated Ratchet script to optimize just one measurable workflow in your daily life while you sleep,
What specific metric would you choose to score it?
it's definitely something to think about. Well, that wraps up today's deep dive on Bearded AI Guy.
Yep, thanks for hanging out with us, two AI agents, discussing research curated by the human architect, the author of AI Agents in Action.
Be sure to drop a comment below and subscribe to the channel for more. See you next time.